Moving into section 5.3. So we're going to step away for a second from talking about the visual ones, although I will mention some connections or some of the polynomial features, and revisit a topic that we talked about a lot in the previous chapter, which is factoring and solving. So in the last chapter, we learned how to factor 4 different ways. We did GCF or takeout factoring. We did difference of squares. We did basic FOIL factoring, which is probably the fastest, and then we also did the AC ones where we looked at multiple techniques that you can do for that one and discussed that there are many ways you do it, and however you choose to do it is fine. So now we're going to kind of piggyback off that and start extending some of those factoring skills and actually learn some new factoring skills in conjunction with what you already know. So this is just kind of going through and talking about what do we know about factors, what do we know about solutions and real numbers and x-intercepts and a lot of the connections we've already been making, and kind of sets up again how do we solve polynomial equations by factoring. Again, we set it equal to 0. That's always the case. We factor as much as we can using as many of those techniques that we've learned, and then we set each factor equal to 0 to come up with our solutions. So I want to just review a few before we get into new techniques. So the question is going to ask us to factor it completely. It's going to ask us any real solution. I am not going to make you find imaginary solutions, but I am going to talk about how do you know if there are imaginary solutions, and then in the end have a list of those real solutions. So we want to start off by putting it in standard form. So we're going to subtract 3x from both sides. So we have 2x to the third minus 5x to the second minus 3x. So when you're going through your factoring, you kind of want to think of it as a checklist. First thing you want to check every time you factor is if you can take out a common factor. In this case, I can take out an x, which leaves me with 2x squared minus 5x minus 3. Next thing you want to do is count your terms to determine what factoring technique is appropriate. So we have 3 terms left in parentheses, which means it's either basic FOIL factoring or AC factoring. This one is AC because it has a number in front of the x squared. So my AC is -6 because I take the 2 times the -3. That's the C value. So I need 2 numbers that multiply to get -6 and add to get -5. That's going to be -6 and 1. So I'm going to go through the way I taught you last chapter, but again, I'll by all means use a technique you're more comfortable with if you'd like. So this would be 2x minus 6 and 2x plus 1. And then before you walk away and start solving, you want to see if anything can divide out. So we can divide a 2 here. So our fully factored answer is x minus 3, and 2x plus 1. So those are our factors. Our solutions are going to come from each one. So we have a solution that comes from each of these x's. So my 3 solutions are 0, 3, and -1/2, -1/2. So we get it in standard form, factor it as much as we can, fully factor it, and then list all of our real solutions. Next one, same thing. We're going to start by subtracting this to the other side. Make sure you put it in right order. So it's going to actually go in between these terms. So we have a minus 6x to the third plus 12x squared. GCF, we actually have a lot here. We can take out a 3x squared, which is going to make this much simpler. We're going to be left with an x squared minus 2x plus 4. Now here you have 3 terms left, and you get to a point where you have to come up with numbers that multiply to get 4 and add to get -2, which there aren't any. So here's where you have a couple options, and I'm going to kind of show you some shortcuts to help. If you get something that you are either having trouble factoring or realize you can't factor, your options are either to immediately go to the quadratic formula or the discriminant of the quadratic formula, or get a visual check of what's happening here. And I think that's the easiest route. So I'm going to grab my calculator. And I don't want all of this stuff here. Hold on. My calculator. There we go. I want to get it so it's just the calculator. And it doesn't want to get that small. Okay, there we go. So I want to take this piece that's in parentheses. I want to go to y equals. I'm going to get rid of whatever was in there from a previous lesson. And I'm going to type in x squared minus 2x plus 4 and hit graph. And this is what you see. You see your parabola. You see part of it at least. And the main thing that you should notice is the parabola never touches or crosses the x-axis, which means when we talked about like quadratic formula and discriminant, which means this has no real solutions. This is only going to be imaginary solutions. So when I said at the beginning, make sure you tell me if there are any imaginary solutions, that's what I'm referring to. We will get an answer. If you set the first part equal to 0, you do get one real solution, and that one real solution is 0. So you will have some like that that will not result in any real solutions when you factor it. Let me show you a couple more here. So this next one is already started being factored. You already kind of have it foiled out. If you look at these two factors, and I purposely did this one to show the difference here. So these two are very similar. They both have an x squared. They both have a number that's a perfect square after it, but one is subtraction and one is addition, and it's a big difference. If it is subtraction, so the x squared minus 1, it will factor as a difference of squares. This factors x plus 1, x minus 1. If it is x squared plus a number, even if that number is a perfect square like 4 is, it will not factor ever. There's no such thing as the sum of squares. Not only with that, it will always result in imaginary solutions. If you were to graph x squared plus 4 in your calculator, it would never touch or cross the x-axis. So therefore, when I write my solutions, from here, I get two solutions. I get positive 1 and negative 1. But from here, I only have imaginary. So I'm going to make a note of that, that's another situation where I could have imaginary. Next one, there is no GCF. So I cannot take anything out in the beginning. This one is 3 terms. This is going to be a basic FOIL factor. I need numbers that multiply to get 63 and add to get negative 16. That would be negative 7 and negative 9. Now, when I break up an x to the 4th, it's going to be an x to the 2nd. So you're going to have x to the 2nd minus 7 and x to the 2nd minus 9. Looking at both of these are both x squareds. They're both subtraction. However, one of them has a perfect square, that would be the 9, and one of them doesn't, that is the 7. I can't do anything if the number is not a perfect square, so x squared minus 7 will not factor anymore, but I can break down the next one into x plus 3, x minus 3, because 9 is a perfect square and it's a difference of squares. So now for my solutions. I actually will get solutions everywhere that I look. I'm going to talk about this one first because it might be the one that's toughest to understand. If I want to know when x squared minus 7 equals 0, I would add 7 to both sides, take the square root of both sides, and get plus or minus the square root of 7. So those are two answers, positive square root of 7 and negative square root of 7. I also get two answers from over here. I get positive 3 and negative 3. So I actually get 4 solutions, positive and negative square root of 7 and positive negative square root of 3. I wanted to make sure you knew the difference between x squared plus a number that would not result in any real solutions. X squared minus the number, you will always end up with 2 real solutions. Sometimes you can factor it further, sometimes you have to use square roots. That is the end of the introduction of 5.3. It kind of takes you through what you know so far and kind of put that into practice. And next couple of videos, we'll show you some new factoring techniques that we're going to add to our list of known techniques.